Right now, highly paid construction site supervisors spend like up to 30% of their day just manually moving text from one software window to another.
Yeah, it's wild. They're essentially operating as highly compensated biological data routers.
Right, and you see this everywhere on a job site.
Right.
Someone reads a PDF, highlights a paragraph, types a summary into a spreadsheet, and then they draft an email about that exact same spreadsheet.
Completely redundant work.
Exactly. We treat human attention like it's cheap infrastructure. And today's deep dive is about utterly destroying that bottleneck. So welcome back.
Glad to be here.
And for you listening right now, especially if you're the kind of person who is, constantly hungry to learn, tired of the endless noise and surface-level tech hype.
Oh, there is so much hype right now.
So much hype. But if you're looking for genuine mechanical aha moments, you are in the exact right place. Today we are examining an instructional curriculum titled Beyond Chat, AI Infrastructure and Automation in Construction.
And we are specifically targeting Lesson A6 today.
Yes, Lesson A6. The mission of this deep dive is to really map out the massive paradigm shift of moving artificial intelligence out of that isolated browser chat window,
Right.
and embedding it as invisible background infrastructure.
Because it really is a fundamental architectural shift. I mean, the majority of the industry is still using AI as a glorified search engine or a text generator.
Yeah, you open a tab, ask a question, copy the answer.
Exactly. But Lesson A6 makes this highly technical, really compelling case that if your AI utilization requires a human being to physically hit the enter key, you are failing to capture the actual enterprise value of the technology.
Okay, let's unpack this.
Yeah.
Because if you think about the workflow, most professionals are doing exactly what you just described.
They copy from a daily log, paste it into an AI interface.
Read the response and paste it back into their project management software. It's entirely manual.
Entirely.
So the curriculum argues that real operational leverage only happens when AI is plugged directly into existing systems as, like, the plumbing.
The invisible plumbing, yeah.
And to understand that, we have to look at the engine making it possible, which is the API. Now, we all know APIs are the backbone of modern software, but the real unlock in this curriculum is how we are shifting from simple, data fetching to autonomous API triggers powered by large language models.
Right, because there is a massive difference between a traditional deterministic API and an LLM API.
How so?
Well, with a traditional API, your software asks a weather database for the temperature in Chicago, and it gets a predictable specific number back.
Right, it's structured.
Exactly. But sending unstructured data to an AI via API fundamentally changes the game. You're sending messy, human-generated chaos.
Like a site supervisor's hastily written daily report.
Perfectly said. You send that mess, and you use the AI API to enforce structure on the way back out. The core principle from the text is that the API allows software to talk to AI with absolutely no human in the loop.
No human in the loop. Let's trace the data on the construction site scenario they provided in the source, because I think it grounds it well.
Oh, that's a great example.
So a site supervisor finishes their shift.
Yeah.
They fill out a messy daily report on their tablet, and they hit submit. Historically, a project manager drinks coffee the next morning, reads that report, hunts for any issues that might cause a delay.
A variation, essentially.
Right, a variation, and manually types those details into a variation register. It's slow, and it's super prone to data loss.
But under the new model, the moment that supervisor hits submit, the system's backend automatically packages that report's text as a JSON payload.
Just a raw data package.
Exactly. And it sends it directly to an AI model, like Claude, via the API. So Claude analyzes the unstructured text, runs semantic matching against the company's predefined criteria for what constitutes a variation,
Wow.
and it extracts the relevant events. Then it formats that data perfectly to match the schema of the company's database and executes a post request to add the new row to the variation register.
Just automatically. But I have to push back here. Because whenever we talk about autonomous AI agents interacting with live company databases, the immediate alarm bells for you, me, and anyone listening are data fidelity and hallucinations.
Oh, absolutely.
Like, wait, programming interface.
Yeah.
Do you have to be a software developer to actually use this on a job site? Or worse, if we just let an LLM write directly to a financial variation register without a human reviewing the prompt, how do we prevent it from inventing a $5,000 concrete overage just because the context was ambiguous?
What's fascinating here is how the source material addresses that exact vulnerability.
Okay.
You don't just send an open-ended query. You use strict parameter controls at the API level,
Like what?
like setting the model's temperature to 0. That eliminates creative variance. It makes the AI highly deterministic. And you utilize force function calling or structured JSON outputs, so the AI physically cannot return anything other than the exact data types your variation register requires.
Oh, I see. So if the daily report mentions a delay but lacks a cost estimate?
The AI doesn't guess. It cannot guess. The system prompt forces it to return a null value for the cost field, which flags it for a human to review.
So it's not just automating the data transfer, it's actively parsing and structuring unstructured field data with really high fidelity.
Precisely.
But realistically, project managers and contract administrators aren't opening IDEs and writing Python scripts to configure API payloads and manage JSON parsing.
No, definitely not.
The friction of deployment for custom code on a construction site is just far too high. So how does this theoretically powerful API actually get implemented by the people managing the site?
Well, that operational gap is exactly why the curriculum introduces the concept of connectors.
Connectors?
Yeah, if the API is the raw, high-voltage electricity, connectors are the localized transformers and wall outlets.
That's a great analogy.
They are the no-code infrastructure that allows non-developers to manage authentication and state between disparate software systems.
So we are talking about platforms like Zapier or Make, or even native integrations like Claude's connectors and ChatGPT's plugins.
Exactly. They abstract away the authentication protocols, the messy oath handshakes, and provide a simple graphical interface.
So you're not coding.
Not at all. They turn system integration into a configuration task rather than a development task. You are just dragging discrete nodes representing different software applications and visually mapping the data fields between them.
Let's ground this in the examples from the text. The curriculum talks about connecting Claude directly to Google Drive,
Right.
which implies we aren't just sending text files. We're utilizing some form of implicit retrieval augmented generation, or RG, right?
Yes, exactly.
So the AI can dynamically search and read a massive folder of project specifications without the user ever downloading and uploading anything.
Yeah, or consider the Airtable connector example. Say a construction firm has a massive relational database of subcontractors. When an issue arises, the AI doesn't just rely on its static training data. It utilizes the connector to execute an active query against that specific Airtable base.
Oh, wow.
Yeah, so it can instantly pull the exact up-to-date insurance expiration dates or, tier 2 contact info, pull it into its working memory, and use it to draft a compliance notice.
Here's where it gets really interesting. This completely democratizes the creation of custom tech stacks.
It really does.
Because think about it, a contract administrator who understands the operational logic of the business, but doesn't know a single line of JavaScript.
Right.
They can drag a webhook node to an email client node, route it through an AI evaluation node, and suddenly they've built a bespoke automation that filters out difficult client emails and drafts context-aware responses.
They are essentially building custom microservices on a Tuesday afternoon.
Which is mind-blowing.
It is. But as the source material points out, once you start establishing these visual bridges, you immediately collide with the structural limitation of how large language models process tasks.
Context windows and system instructions.
Exactly. Because even if you successfully pipe an email payload into the AI via Zapier, the AI still wakes up completely amnesiac.
Right, it's a blank slate every time.
Right. It doesn't know your company's tone of voice, it doesn't know the project history, and it definitely doesn't know the highly specific formatting rules for your particular documentation.
So you end up in a situation where the data routing is automated, but the prompt engineering becomes the new bottleneck.
Precisely. You have to inject paragraphs of rules, context, and formatting constraints into the payload every single time the trigger fires.
Which is highly inefficient.
Yeah.
And it increases the risk of the model, just losing the thread of the actual task.
Yeah. So the curriculum solution to this architecture problem is packaging the AI's brain into what they call skills.
Skills. Let's break down the mechanics of a skill. Because we aren't just talking about a save text prompt you copy from a Word document, right?
No, not at all. A skill is a reusable, pre-configured architectural layer. It isolates the system instructions from the user data.
Okay.
And it locks in 3 critical components. First, the foundational system prompt, which dictates the AI's persona and operational parameters.
Got it.
Second, the static context, which might be the overarching project rules or company standards. And third, the explicit step-by-step processing logic you want applied to any incoming data.
So the source mentions Contractor OS as a prime example of this. It's like a library of these pre-built, highly optimized skills specifically designed for construction workflows.
Yeah, take their daily report analyzer skill. The beauty of this is the separation of concerns, the complex prompt engineering, the zero-shot or few-shot examples of what a valid variation looks like, the strict output schemas.
All the nerdy stuff.
All the nerdy stuff is completely hidden from the end user. The user interface simply asks for the daily report PDF.
Oh, that's clean.
Right. The skill intercepts that PDF, wraps it in the pre-configured system logic, processes it, and outputs the exact requested table format.
It's essentially like writing a hyper-detailed standard operating procedure, an SOP for a digital worker, hitting save, and never having to explain the rules to them again.
That's a great way to look at it.
You transform a fragile, multi-paragraph prompting exercise into a robust, single-click function. You just pass the payload.
And it reduces the cognitive load of utilizing AI down to near zero. But while a skill optimizes a single isolated task, like analyzing a report or summarizing a document,
Right.
construction management is rarely a series of isolated tasks. It is a highly complex environment of administrative chain reactions.
Which means we need to look at how we orchestrate these isolated tools into a cohesive system.
Exactly. That is the core of the ultimate leverage discussed in Lesson A6, multi-step automations.
The holy grail.
Basically, yeah. This is the synthesis of connectors handling the data transport and skills handling the cognitive processing chained together into autonomous workflows. The curriculum reduces this to a mechanical formula: trigger plus AI action plus output.
Trigger, AI action, output. Let's trace the request for information, or RFI flow, detailed in the text. Because RFIs are notoriously brutal administrative bottlenecks.
They're the worst.
They involve multiple stakeholders, technical documentation, strict contractual timelines. How does the formula map to this specific workflow?
So the trigger is an external asynchronous event. A new email hits a specific inbox and a webhook fires because the subject line rejects matches the term RFI.
Okay.
That webhook is the trigger. Zapier intercepts the payload, extracts the raw text and any attached PDF schematics, and routes it forward.
So the data has been captured and structured without a human even opening an email client.
Exactly. Moving to the AI action phase, Zapier pushes that extracted payload via API into Claude, specifically routing it through a pre-configured RFI analysis skill.
Right.
The model analyzes the technical language of the subcontractor's question, cross-references it against the embedded project specifications, and generates a highly technical, contractually accurate draft reply.
But an AI drafting an official RFI response based on structural schematics introduces a massive liability.
Huge liability.
Right. If the AI hallucinates a load-bearing tolerance in its draft, and that gets sent automatically to an engineer, that is a catastrophic failure.
Which is exactly why the output phase in the curriculum's example is critically designed with a human-in-the-loop failsafe for high-liability workflows.
Oh.
Okay, automation doesn't send the email.
Thank goodness.
Right. The output action dictates that the system logs the original question into the Airtable RFI register for tracking and then pushes the AI's generated response into a specific drafts for review queue in the project manager's inbox.
That makes so much more sense.
The AI has done 90% of the heavy lifting: the data entry, the cross-referencing, the initial drafting.
Yeah.
The human professional steps in purely for the final 10%, the expert verification and approval.
Trigger, AI, action, output. And the source lists several other high-impact examples utilizing this exact architecture.
Yeah, there are tons.
Auto-routing subcontractor invoices is a fascinating one. The system triggers on an incoming invoice. The AI utilizes semantic matching to align the line items against the company's specific chart of accounts, and then automatically assigns the correct cost codes in the accounting software.
Yeah, or feeding raw audio transcripts from a tool like Fireflies into a skill that dynamically generates formal, meeting-minute templates.
If we connect this to the bigger picture, you start to see the cumulative impact. Think about the friction of modern knowledge work for a second. It isn't the complex problem-solving that burns people out.
No, it's the busy work.
Exactly. It's the endless data shoveling. Reading a PDF to update a tracker, to draft an email. What the source material demonstrates is that we now have the architectural tools to chain those data buckets together, allowing the AI to handle the transport and formatting autonomously.
It's revolutionary, really.
It sounds incredibly powerful. But if I'm listening to this right now and mapping this against my own messy, chaotic project data, It also sounds highly brittle.
Oh, it can be.
Right, like multi-step automations involving webhooks, APIs, and AI processing nodes have a lot of potential failure points.
Yeah.
How does an organization actually implement this without it just collapsing under its own weight on day 2?
That is the single most common failure mode in automation deployment. Teams try to architect a fully autonomous 10-step invoice processing system on their very first attempt.
They try to boil the ocean.
Exactly. And the AI inevitably encounters an edge case, the JSON schema breaks, the connector fails. The team loses trust in this system, and everyone reverts to manual data entry.
Right back to square one.
Yeah. So Lesson A6 provides a strict philosophical roadmap to combat this brittleness. And the rule is, start impossibly small.
The text advises isolating the single most repetitive, mind-numbing document task in your weekly workflow. Not the most strategically important task, and certainly not the most complex one.
No, you identify the mundane chore. If you spend 3 hours every Friday formatting progress reports from raw daily logs, start exactly there.
Just that one thing.
Just that one thing. Build a simple connector. Wrap the logic in a basic skill, and run it in parallel with your manual process until you verify the outputs are rock solid. Do not add a second node to the workflow until that single task is executing flawlessly.
The maxims from the source are brilliant. One working automation beats 10 broken ones. And momentum beats ambition.
Ambition builds fragile systems. Momentum builds resilient operations. When you successfully automate that Friday report, you don't just win back 3 hours.
What else do you get?
You prove the viability of the infrastructure to yourself and your team. You establish a baseline of trust in the AI's deterministic capabilities. Once that trust is established, then you move to the next friction point. You build the network one reliable node at a time.
So what does this all mean for you listening right now? I want you to mentally audit your own weekly workflow. Identify the administrative chore that requires you to manually parse data from one format and type it into another.
The one you dread doing every week.
Yes. The task that feels like it should be done by a machine. That is your deployment target. Don't try to overhaul your department's entire tech stack. Just solve that one specific data bottleneck.
Grounding the abstract architecture in immediate, localized pain relief is the only way to successfully drive adoption.
We have covered a massive amount of technical ground today, so let's lock in the core mechanics of Lesson A6 before we wrap up.
Sounds good.
First, the API. This is the underlying engine that allows us to bypass the chat interface, enabling programmatic software to AI communication that enforces strict data schemas without a human hitting enter.
Second, connectors. These are the visual OAuth bridges like Zapier or Make that allow non-developers to route payloads between disparate platforms, turning integration into a configuration exercise.
Right. And third, skills. The architectural layer that permanently packages your system, prompts, context, and formatting rules so the AI executes reliably on single-click payloads.
And finally, multi-step automations. Chaining those connectors and skills together using the trigger AI action output formula to orchestrate complex workflows. And doing so with the discipline that momentum beats ambition.
Exactly.
You know, this raises an important question to close on.
Oh.
Yeah, if we extrapolate this architecture forward, if API triggers and multi-step automations successfully take over the background infrastructure, autonomously extracting the variations, routing the RFIs, semantic matching the invoices to cost codes, and generating the progress reports.
Yeah.
What is the actual role of the human professional in 5 years?
That is the existential question of this entire technological shift, isn't it?
It really is. Currently, the industry compensates professionals heavily for their ability to accurately process and route data. But when the friction of that paperwork is eliminated by invisible AI infrastructure, we can no longer hide behind busy work.
Right. We transition from being data processors to purely functioning as decision makers, strategic leaders, and complex problem solvers.
The automation isn't just replacing a workflow, it's forcing a complete evolution of our professional identity.
When the invisible plumbing of a building is working perfectly behind the drywall, you stop thinking about the pipes entirely. You finally have the freedom to focus on what you actually want to build inside the room.
Well said.
Thank you for joining us on this deep dive. Your mandate for this week is clear. Find that one localized data bottleneck, build a single node of automation, and establish your momentum. We will catch you on the next one.